Welcome back to the girls' room.
I'm Hannah.
I'm Lori.
I'm Rose.
This week on the girls' room, we're going to be talking about the budget line, as shown right here, as well as indifference curves between days of skiing per semester and days of horseback riding per semester.
Now let's talk about indifference curves. Here shown, the indifference curves are the green downward sloping lines. V and WX are all points on the farthest indifference curve to the right. Indifference curves show the combination of two goods or events, in this case, days of horseback riding per semester and days of skiing per semester, that represent the same total utility. Utility is the total satisfaction of consuming a good. So for instance, point V represents the same total utility as point X. As you move from point V to W to X, your days of horseback riding per semester is increasing. This means your marginal utility for days of horseback riding is decreasing, because with each day you allocate per semester, your total utility is less. The increase in your total utility is less than the day before. This means the marginal utility for days of skiing per semester coming down the curve is increasing. It decreases from V to W to X and is negative because you are giving up something to gain something more of the other. So if you give up a day of skiing, you allocate that to days of horseback riding.
Now that you have a better understanding on what the indifference curve is, I'd like to go over the budget line. Our total budget for this problem is $200. What we're doing is days of horseback riding per semester and days of skiing per semester. For each option, skiing or horseback riding, it's going to be $40 a day. So our total budget is a constraint. That means we can't have any more or any less. For every combination that will take place on the budget line, the total will be $200. If we do 5 days of horseback riding per semester, that means we'll have 0 days of skiing per semester. And if it's 5 days, you do 5 times 40, which is the cost of skiing or horseback riding per day, and that will be $200. On the contrary, if you did 5 days of skiing per semester, that would be 5 times 40, which is the cost of skiing per semester. That would also be $200, and you would not be able to go horseback riding at all.
Now I'm going to explain the budget line and the different combinations of horseback riding and skiing that you can have when you go along it. At point S, you can have 4 days of skiing and 1 day of horseback riding. If you move along the budget line to point D, you can have 3 days of skiing and 2 days of horseback riding. And then when you move along to point X, you can have 2 days of skiing and 3 days of horseback riding. Just to clarify, over here, so if you put all of this together, you can get 4 days of skiing and 1 day of horseback riding at point S. So 4 days of skiing times the price of $40 gives you $160, and 1 day of horseback riding at the price of $40 gives you $40. So 160 plus 40 equals $200, and that's your total budget. At point D, if you were to have 3 days of skiing at a price of $40, you get $120. At 2 days of horseback riding times $40, you get $80, and this totals up to be $200, which is also our budget. And then at point X, you get 2 days of skiing, 2 times 40 is $80, and 3 days of horseback riding, 3 times 40 is $120, and when you add these up, you get the total budget of $200. So all 3 of these points are on the same budget line and have the same exact budget, but they have 3 different combinations of total horseback riding and days of skiing. I'm going to explain how to get the equation of a budget line. For any given line, the equation is y equals mx plus b. For this graph in particular, the y-axis is days of skiing, and the x-axis is days of horseback riding, and that's why we replaced these here. For any given budget line, the slope is also negative. So instead of rise over run, it's actually run over rise. And we have here the negative price of horseback riding over the price of skiing times horseback riding plus the y-intercept. And this simplifies to S equals negative H plus 5. And that's the simplified equation of our budget line. So for example, if we were to plug in 1 day of skiing, we'd have 1 equals negative H plus 5. And in simplifying this, we get positive H equals 4. So for 1 day of skiing, you can get 4 days of horseback riding. And back to the y-intercept, this is actually provided in the problem. And for this, it's saying that if you spend all of your money on skiing alone, you'll get 5 days of skiing and no days of horseback riding.
I'd like to inform you about the marginal rate of substitution that deals with the budget line. What the marginal rate of substitution is it's the negative slope of the budget line. As you can see, it is a negative slope right here. The reason that is because the reallocation of money from one good to the other. So if we were to start right here at days of skiing and spend all of our money on the days of skiing, we do receive 5 days of skiing. But if we were to reallocate it and spend 1 day on horseback riding versus all 5 days on skiing, you go down, and instead of spending $200 on total on skiing, you spend $160 on skiing and then $40 on days of horseback riding, thus creating the negative slope of the line. Now we're going to talk about the point at which the individual's utility has been maximized subject to their budget. So we were given a specific budget. In our example, it was $200. With that $200, we can only spend money along this budget line with the different combinations of those two goods. We were also given the indifference curves. We have 3 different levels of indifference curves. We also informed you earlier that you want to go to the highest indifference curve, the one that's farthest away from the origin, so that you can gain the most utility, because if you're down here, you don't gain as much utility as if you were up here. And everybody wants to gain as much as possible. So our point where the utility has been maximized subject to the budget is at point X right here. As you can see at point X, the budget line is tangent to the indifference curve. So the reason we're at point X on the indifference curve is because it is on the highest indifference curve. Thus, we're getting the most we can. And the budget line, we use all of our budget in order to maximize. And if that point has hit our indifference curve at the maximum point on the indifference curve, then we have maximized our utility.
Thanks so much for tuning in to this week's Girls Week. Can't wait to see you next week. Bye!
Lori just getting ready for the big show.
Thank you.
Oh, that was on Zoom.
Do you get that?
Yeah, but I'll do that for a second.
Okay, do you want me to erase this right now?